Hi, we're in New York City's Times Square. People from all over the world come here on December 31st to ring in the new year. But we're here today to do some
Somebody let me out of this white trap!
carpool chemistry. Today, we're going to learn how to draw Lewis structures for compounds. In a previous edition of Carpool Chemistry, we learned how to draw the Lewis dot structure for a single atom. For example, carbon has 4 electrons in its outer energy level, so we put 4 dots around carbon, like this. But what happens when carbons combine with other atoms? How does it behave? Let's find out by drawing the Lewis structure for this compound that has 1 carbon atom and 4 fluorine atoms. Well, these atoms are linked together, but in what pattern are they linked together? They could be linked together with carbon coming first, and then fluorine, and then another fluorine, and one more fluorine. Or it could be carbon with, fluorine first, and then carbon, and then fluorine, and fluorine. Or it could be fluorine, carbon, fluorine. There's many different combinations that they can link up as, but what is the best combination? Well, we turn to some of our general guidelines that we've studied, and that is, number 1, we want to draw the skeleton structure using single bonds. Sometimes more than one arrangement is possible. If you have hydrogen in your compound, it forms only one covalent bond because it's stable with 2 electrons. Here's where we get to the task at hand. Each carbon atom typically forms 4 bonds with no unshared pairs. That is, carbon wants to be centrally located. So let's put carbon in the middle over here, and it says that carbon wants to form 4 bonds, 1, 2, 3, 4. And do we have 4 other atoms to put on the other end of these bonds? Yes, we do. We have 4 fluorine atoms right over here. Now the question is, do we have enough electrons to make this happen? As we know, the outer shell valence electrons are like pieces of glue that hold these compounds together. Do we have enough pieces of glue to make this happen? In order to determine that, we need to write down what we call an electron tabulation. And it's like accounting for electrons. So let's take a look at carbon. There's 1 atom of carbon, 1 atom. And how many outside valence electrons does this carbon atom contribute to this structure over here? From our periodic table with the boxes on the side showing the outer electrons, we see carbon contributes 4 valence electrons. 4 valence electrons is equal to 4. Fluorine. There's 4 atoms of fluorine. 4 atoms. And how many outside valence electrons does each atom of fluorine contribute? They contribute 7. So 7 valence electrons is equal to 28. And so it looks like we have 4 plus 28 is equal to 32 total valence electrons, or pieces of glue, holding this structure together. Is that enough? Or are we going to have to double up on some of these bonds to turn them from single bonds into double bonds if we don't have enough electrons? Well, let's take it a step further. We have 32 valence electrons, and of those 32, we need to account for the fact that each of these bonds over here require 2 electrons to make that happen. So, like it says right over here is, count the number of, deduct 2 valence electrons for each single bond. And so we have 1, 2, 3, 4 single bonds. And so single bonds 4 times 2 electrons per bond. That means out of these 32, we have to deduct 8 for those bonds that we just made. So that leaves us 32 minus 8 is 24 valence electrons left over. Let's take a look at these atoms inside of our structure. This fluorine at the top, as we see here, there are 2 electrons associated with this fluorine. How many total fluorine, how many total electrons does this fluorine really want to have? They want to have 8 in order to be stable, that stable octet. Do we have 8 electrons in our pile of electrons down over here? We sure do. As a matter of fact, we have 24 of them. And so let's go ahead. It looks like it needs 6 more because there's 2 from here. It wants a total of 8, so it needs 6 more. 1, 2, 3, 4, 5, 6. And so from our first fluorine at the top, we used up 6 of those 24 remaining electrons to form the stable octet around fluorine. Looks like we have 18 more. Over here, this fluorine also needs 6 more valence electrons to make it stable. Do we have 6 available to it? We sure do. As a matter of fact, we have 18 of them. So take away 6 to account for those over there. And then this fluorine down at the bottom also needs 6. Do we have 6? We sure do. We have 12 remaining. So of those 12, let's use 6 of those for that fluorine at the bottom. Leaves us with 6 left over. And this fluorine on the left over here, it also needs 6 more electrons. And so we put 1, 2, 3, 4, 5, 6, and we use up our last 6. We have no more valence electrons remaining, and each atom inside this structure over here is satisfied with the stable 8 electrons around it. Fluorines, as we just showed, has 8 each, and then this carbon, because each bond requires 2 electrons, this carbon has 2, 4, 6, 8 electrons around it. So this is the Lewis structure for the compound that contains 1 carbon and 4 fluorines. And that's how you draw it. From Times Square in New York City, this is Carpool Chemistry. Thanks for watching.